And now it's time for
a tiny bite
of knowledge. So one of the really fun things about phosphorus is that there isn't just one phosphorus test out there.
No kidding. I have gotten soil tests in to work with customers that have all different kinds of numbers on them from different analysis methods. And it is really confusing sometimes to try to help customers think through what those numbers actually mean.
Yeah, and so there's actually 3 main soil test phosphorus tests available for folks that are submitting soil tests to choose from. And those include the Bray 1, the Olsen, and the Mehlich-3 soil phosphorus tests. And what's really important to know about these 3 is that if you were to, they're not interchangeable. So if you were to submit one single soil sample and get them tested for Olsen phosphorus, for Bray 1, and then for Mehlich-3, you're probably going to get a different phosphorus test from each one of those tests. Again, they're just not the same. And so why is that? How does a person actually choose which method is right? Oftentimes, like say if you were to do a soil test, or like say if you were to do an Olsen phosphorus test on something and it comes back with like a 6 ppm Olsen, which is relatively low, which you'll typically come back with for like a Bray 1 test is maybe something 2.5 times more than that. So like 15, something like that. And there's not really a good straight back and forth between Olsen and Bray 1. And that comes down to the fact that Bray 1 isn't really suited for soils here in the Northern Great Plains. And before I get back into that too, like when we think about what soil extractant is correct for an area, it all comes down to A, whether that extractant is suited for the soils they're working on, and B, if you actually have soil test correlation and calibration data. Or what I mean by that is field data that shows that if you have a soil test phosphorus level of X for that extract, you need X amount of fertilizer to get increased yields that year. So it's really important that you don't just need a soil test phosphorus result. You also need those guidelines that go with that. And that comes from the state universities doing the testing to see how much additional phosphorus you actually need to increase yield with that soil extract.
Yeah, so just to kind of think about that then for a second, you could run the same soil test, and let's just say that it is a soil pH of 6.7 or 7.0. Pretty, not too acid and not too high in pH either. You run that with these different analysis methods, you're going to get very different numbers.
Yes, you'll have a higher number with Bray. You might get similar numbers with Mehlich-3.
But you may not.
Yes.
And then Olsen will kind of be very unique to itself. And it has to do with the extractant that's getting used, and it has to do with whether that extractant is the appropriate way to analyze that phosphorus for that particular soil situation.
Yep.
So, okay, Jody, that's great. Talk to me about the Bray test, Bray 1.
Yeah, so soil testing, it's been around for, probably almost over 100 years now. But this Bray 1 method was pretty much the first soil test phosphorus method, and it was developed in 1945 in Illinois. And so this is really designed for soils that are acidic or neutral to acidic, and the extractant itself is an acid. So like what'll happen in soil testing is you have a soil sample, you'll add like the Bray 1 extractant to that soil sample, and it's going to extract from that soil plant available phosphorus. And so again, Bray 1 works really well in Illinois. It correlates really well to yield and phosphorus needs for that area. But what happens is that when Bray 1 is used on calcareous soils or soils that have free lime or calcium carbonate in them, that part of that acid extractant is neutralized. So that Bray 1 extract is neutralized by the carbonates that are in there, and it under extracts the phosphorus there, meaning that you'll get a decreased result at the end and you'll over apply phosphorus. So in response to this, there was a researcher in Colorado named Dr. Olsen that in 1954 developed a phosphorus extract that was better suited for calcareous soils. And so this extractant, the Olsen P method, works well on acidic, neutral, and basic soils. And that's because when we use this extractant on calcareous soils, those soils with free lime, the extractant isn't neutralized by the soil itself. And so this is why the Olsen method is the primary soil test method that's used in the Northern Great Plains, where we have soils that are mostly calcareous into neutral and into acidic as well, and sometimes even in the same field. And so a really common question that I used to get and still get today is, I've got a field that's got both acid and basic soil pHs, so like a field that ranges in pH from 6 all the way up to 7.5. Should I use the Bray 1 on those lower parts of the field and then the Olsen on the higher? No, what you want to do is you want to make sure you use the same extract across the whole field, and you'd want to use the Olsen method because it works well on both those acid parts, the neutral parts, and the high pH parts of those fields.
That makes perfect sense. And a lot of times when we first see soil samples coming back analyzed for phosphorus across the United States, it sure feels like we see an awful lot of Bray 1. But there are certainly some soils where that is not appropriate at all. Higher pHs, those calcareous soils, we really need to think about incorporating those Olsen phosphorus testing methods.
Absolutely. And like I'll mention later too, but if you ever have questions about what's appropriate for your fields, ask the soil test laboratory that you're sending them to, or ask the agronomist that you're working with. They should know what the appropriate method would be for your phosphorus. And, one thing we haven't talked about here either is the third phosphorus soil test method, and that is the Mehlich-3 method. And I've been seeing a lot more of this over the last couple of years. The Mehlich-3 method is the newest soil test method that's out there. And when I say new, what I mean is that it was developed in 1984 instead of the 50s and 60s. And it was kind of developed as like this universal soil extract. And what that means is that the Olsen and the Bray 1 methods are both very specific to phosphorus. When you're doing the Bray 1, when you're doing the Olsen P methods, you're only extracting and measuring phosphorus. But with Mehlich-3, you have the ability to not only measure phosphorus, but then you can also measure other nutrients that can be measured on like an ICP. So you can potentially extract and measure potassium, calcium, sodium, other things outside of phosphorus. And
so micronutrients
and like things like your micronutrients too. And so like from a soil testing perspective and like from a farmer perspective, you might look at Mehlich-3 and say, oh, well, hey, I can get Mehlich-3 done a lot cheaper and I can get all these other nutrients done too. Why don't I just do that? But here's the deal, like we talked about before, soil test phosphorus methods are specific to areas and different soil types, and they also need that university tested correlation and calibration piece to provide accurate guidelines with those soil test results.
So Jody, what really is calibration? When we think about universities calibrating these soil testing methods, what are we really thinking about these universities doing to make these soil testing methods accurate to different geographies and different places around the United States?
What that means is that you have researchers that are going out and putting out test plots and yield studies in different parts of the state that they're researching, and then also measuring yield. You've got your non-treated at a certain baseline level, and then you've got like a plot that's included that is not limited by phosphorus. And then what you're trying to figure out is, if I start at a certain level of phosphorus, soil test phosphorus level, how much additional phosphorus fertilizer do I need to get to a point where I'm maximizing yield? And so these trials are done throughout a state. They're done multiple years, multiple areas. All these different soil types are included in these so that you're getting an accurate yield curve, which what you typically see this as are guidelines that are published by the university that say, hey, if you have a Bray 1 phosphorus level of 15, you need X amount of additional phosphorus fertilizer that year. Same thing for Olsen, same thing for Mehlich. And so the problem with like Mehlich-3 is that some states have guidelines developed for these and others don't. And you might think, oh, well, Do we just have some lazy soil scientists that haven't developed the Mehlich-3 correlations yet and guidelines? No. For instance, just a couple of years ago, the University of Minnesota tried to produce those guidelines for the state of Minnesota. But what the researcher found is that the Mehlich-3 extract doesn't work across the whole state. It fails on areas that have calcareous soils like we typically do here in the Northern Great Plains. And so if your state doesn't have a correlation set or like a guideline for a specific soil test phosphorus method, it's most likely because that method is not suited for your area. And you should be using the phosphorus method that is suited for your area.
Think about what that concept of calibration is. Really what they're doing is, okay, you've got a soil, you analyze that soil with each method, and you've gotten a number. Okay, Mehlich-3, maybe it's 43 parts per million. Olsen, maybe it's 9 parts per million. Bray, maybe it's 12 parts per million. Those numbers are not the same, but you've extracted the available phosphorus, and that's what those have read. Now what we're doing with the calibration component is at those levels of extracted soil available phosphorus, we are running yield trials to see how much additional phosphorus it takes to be at a point where we're not limited by phosphorus anymore. Is that correct?
That's absolutely right.
And to your point, I think it's very interesting that, we're talking about these soil tests that have been developed in 1945, 1954, and 1984. We think that that's so long ago, and yet we are not really in a time or place right now with ag research where we are developing new soil analysis methods to manage our soil fertilizer. And furthermore, it feels like it's tough to be updating our calibration with the current tests that we have. And so within that, like in North Dakota, for example, we do not have calibration information for the Mehlich-3. And considering that Minnesota just found out that Mehlich-3 isn't suited very well for soils that are calcareous, and we think about the number of calcareous soils that we've got in North Dakota, it would be really tough to make good recommendations with a Mehlich-3 soil test analysis. Am I understanding you correctly with that, Jody?
Absolutely. If it doesn't work in Minnesota because of calcareous soils, we're going to have the same issue here in North Dakota. But the beautiful thing, like you just mentioned, Sarah, right? Like the Bray 1 and the Olsen phosphorus method, they've been around quite a while. And so we do have a lot of data that backs up these calibration curves. And yes, we can talk about, how hybrids change things and maybe it shuffles phosphorus around the plants a little bit differently. But at the end of the day, we have a lot of data that backs up the correlation and calibration guidelines that we have here in the state of North Dakota, in Minnesota, and South Dakota, here in the Northern Great Plains. Again, as you go across any university guideline system, there's a lot of data that backs up what they're publishing and putting out to growers. And so it's really crucial that if you have questions about what soil test phosphorus method that you should be using on your farm, call your soil testing lab, call your soil fertility extension specialist. They will know what method is appropriate and will have that knowledge and that background to help guide you in the right direction.
Call your agronomist. They know. I've had a lot of conversations with agronomists over the years in the independent crop consulting world and retail where we talk about, that farmer that picked up that new piece of land and he paid all that money. And when you looked at the Olsen phosphorus test, he only had 2 parts per million of phosphorus out there. And we know just by having these conversations, we know what that soil testing level means because we have seen these things in the fields. People understand what that number means and what it looks like. We know what crops look like when they're in soils that have, a 10 to 12 part per million Olsen phosphorus or 16 to 18. We know what these things look like because we've seen them and we know what those numbers mean. That's the calibration component of it.
Yeah. Yep. And if you're listening to Sarah and think, I don't know what a 2 means, I don't know what a 16 to 18 means, NDSU for this specific area has those tables posted and you can take a look and see that 2 is very, very low. That's not good. And then 16 to 18 is above like their quote unquote critical level. And that's very good. So if you don't know what those numbers mean, consult your local resources. They will have guidelines that tell you where those numbers fall into.
And that is true for the Bray and the Bray 1 where where that is a common soil testing method for those soils. And that is also true for the Mehlich-3 in the areas where that test has been calibrated as well.
Absolutely. That's a fantastic point. But yeah, we've had a fantastic conversation here today about the three main types of soil test phosphorus. And really, at the end of the day, it's so important to know what your phosphorus levels are. Don't guess, soil test.
Don't guess, soil test. Tune in next time
For a tiny bite
of knowledge
from GK Technology,
where we have a map
and an app
for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.